Good morning, I am Mr. Ish. Thank you for joining me. In this video, we're looking here at the concept of sequence of numbers. Relatively, students think of this as an easy topic, determining if a sequence is an arithmetic sequence or if it's a geometric sequence. And that might be true that it is easy, but the minute the sequence becomes a little hard or difficult or tricky, then sometimes they have a problem. The goal of this specific video is to introduce you to this topic in a formalized manner, but to simplify it for you so that no matter what the sequence is, you should not have any problem. When you're looking here at a sequence of numbers, you know what you're looking at. Any sequence of numbers or digits and the relationship between one to the next. If you have a specific sequence, just for terminology reasons, let's just say here we have A, B, C, and you know you're going onwards. If this right here represents a specific item, let's just call that x to the n, my nth term. Then the item before is x to the n minus 1, but here the n and the n minus 1 are subscripts, they're not superscripts, so that's what we're looking here. The nth term and then the term right before. For an arithmetic sequence, if you're looking at whatever term in your sequence, we'll call that the nth term. There is a specific common difference which appears between each number. From one number to the next, you have a same difference which appears, and that term x to the n and the term right before it will always have this common difference, and it's called a d, a common difference. So if you're looking at a sequence such as 1, 2, 3, 4 all the way, you know each of these terms has a difference here of a 1. 4 minus 3 is a 1, 3 minus 2 is a 1, 2 minus 1 is a 1, so you have a common difference here of a 1. When you have a relationship where each number is successively ahead of the other by a common difference, that right there represents an arithmetic sequence. So you have to keep that in mind. You have the main item here with regards to an arithmetic sequence, the common difference. When you're talking about a geometric sequence, you don't have a common difference. Here you're looking at a ratio. You're looking at the ratio of an nth term in your sequence and then the term right before it. X to the n divided by x to the n minus 1. There's a common here, a ratio, a common ratio develops. Here we had a common difference, here we have a common ratio. If you had a sequence over here, and let's say as an example 10, 100 and 1000, you can imagine what will be the next 10,000. You're looking here 10 to the 1, 10 squared, 10 cubed, 10 to the 4. If you were to evaluate each of these in terms of a common difference, you won't have a common difference. The difference between 100 and a 10 is 90. The difference between 1000 and 100 is a 900, and you can imagine the difference is not the same. There is no common difference, but there is a common ratio over here. The nth term and the term right before it is always equal to another nth term and the term right before it. In all of these instances, there will be a common ratio. In all of these instances, the common ratio is always 10 to the 1 or just 10. Each is, in terms of a quotient, 10 times the one right before. 10 times 10 is 100, 100 times 10 is 1000, 1000 times 10 is a 10,000, so you have a common ratio over here. This common ratio here leads you to conclude that something which looks like this is a geometric sequence. So with that little bit of background that we have, now let's examine a few examples. Let's look at this right here. We have something which looks like this: 2, 4, 6, 8, 10, 12, and going onwards. You have to determine if this is an arithmetic sequence or a geometric sequence. For an arithmetic sequence, you know you're always looking at one number and the number before and the difference which exists. Let's just take these two numbers. You'll do 4 minus 2, you're getting a 2. Pick any other two numbers, you'll do 10 minus 8 and you're getting a 2. You're seeing here a common difference arise, but you always have to test everything for geometric sequence as well. Take any two numbers, do 4 divided by 2, the number and the number before, you're getting a 2. Take here 10 divided by 8 and you're gonna get a 5 over 4. You don't have a common ratio, but you do have a common difference. So when you're looking at something like this, you have right here an arithmetic sequence. And remember, some sequences can be neither arithmetic or geometric, in which case what you're looking at is a neither sequence. But this right here clearly is an arithmetic sequence because there's a common difference which is appearing. There's no common ratio over here. Take a look at this sequence: 2, 4, 8, 16, 32, and onwards. Evaluate this for being an arithmetic or a geometric sequence. Well, pick any two numbers and see the difference between those two. This here would be my x to the n term. This here is the term right before, x to the n minus 1. In this instance, xn and x minus 1 is 8 minus 4, which is a 4. Pick another term right over here. We have 16 and 8. If you do 16 minus 8, 16 and an 8, you have a difference here of an 8. So you're not seeing a common difference here. It's not an arithmetic sequence. Now we have to evaluate for a geometric sequence, in which case you're taking a term and you're dividing it by the term before. We'll do 8 divided by 4. I have a ratio here developing of a 2. And let's look at these two terms. We'll do 16 divided by 8. And I'm having a 2. Let's do 32 divided by 16. Remember, it's always your term and the term before. Don't skip terms in terms of a big gap between, because then you're not going to see that ratio or difference develop. And here you're seeing 2. In this instance, we're seeing a common ratio develop. So this right here represents a geometric sequence. And that's exactly what it is. Let's look at one more question in terms of understanding. Then we'll look at our 2 questions for this particular video. Our sequence is this: 1, 7, 19, 31, 57, 69. Pick any 2 terms. We have to evaluate this for being arithmetic or geometric. When you're doing the 7 minus 1, you're getting a difference of a 6. Pick another 2 terms, 19 and 7. When you're doing 19 minus 7, what are you going to get? You'll get a 12. You definitely don't have a common difference, so it's not an arithmetic sequence. You can pick the same 2 terms if you want and do the ratio of these numbers. You can do 7 divided by 1. Remember the term and the term before. You're getting a ratio here of a 7. And then pick the next two, 19 divided by 7. And it's not equal to 7. You definitely do not have a common ratio here developed. It's not a geometric sequence. It's not an arithmetic sequence. You can classify this as neither. And that's exactly what it is. It's neither arithmetic and it's neither geometric. There's no common difference and there's no common ratio developing between the sequence of these numbers. Let's look at this one right here. We have to evaluate. We have the sequence pi, 2 pi, 3 pi, 4 pi, 5 pi onwards. And we have to evaluate this as being either a geometric or a arithmetic sequence. And how would you go about doing it? Just pick any 2 numbers. This is my x to the n. That right there is a term right before. When you do for the arithmetic sequence test, you're doing x to the n minus x to the n minus 1. You'll be doing a 3 pi minus 2 pi and you'll get a pi. In all instances, as you do the number and the number before, you'll always get a value here of a pi. 5 pi minus 4 pi is just a pi. Let's do it for a geometric sequence. Pick these same 2 numbers, x to the n divided by x to the n minus 1. Here you'll do 3 pi divided by 2 pi. The pi's will cancel out. You'll have a ratio here of 3 over 2. But pick another 2 numbers. Pick these 2. You'll do 5 pi divided by 4 pi. The pi's will cancel out, but you'll have a ratio here of a 5 over 4. So there's no common ratio developing here, but there's a common difference. And it's definitely not a geometric sequence, but it is an arithmetic sequence. So this right here is clearly a arithmetic sequence. And that's exactly what you have over here. Let's look at this sequence: e square, e cube, e4, e5, e6. You know what the series is. Exponent is increasing by a unit 1 each time. Arithmetic sequence, is it or not? Pick these 2 items. We'll do x to the n minus x to the n minus 1. Here's x to the n minus 1. You'll do e to the 4 minus e cube. You can pick another 2 numbers. You can do e to the 6 minus e to the 5 and see if there's a common difference which arises. You'll have to bring a calculator. Very likely you don't see that common difference. Let's do e to the 4. E to the 4 minus e cube. You're getting here 34.5. Now let's do e to the 6 minus e to the 5. You're getting a 255. So definitely you're having values over here which are not a common difference. So it's not an arithmetic sequence, that's for sure. What about a geometric sequence? You know you're doing x to the n divided by x to the n minus 1. Pick these same values again. You're doing e to the 4 or e cube, and you also had e to the 6 divided by e to the 5. In all instances, you're cancelling these things out and you're having a common ratio here developing of an e. e4 divided by e cube is e to the 6 divided by e to the 5 is the e. So you have a common ratio developed, and this ends up being a geometric sequence, and that's exactly what it is. So this question has been completed. I'm just closing here this video with this extra question. We can just do it very quickly, then we'll be done. And it'll be an interesting question to look at. Our sequence is 1 over 2, 1 over 3, 1 over 4, 1 over 5. You have to evaluate this as geometric or arithmetic. Let's pick these 2 numbers here, and we'll pick these 2 numbers here. In terms of an arithmetic sequence, you're doing x to the n minus x to the n minus 1. Let's see, you'll have 1 over 3 minus 1 over 2. That's one set of difference we have to calculate. Then you'll have 1 over 5 minus 1 over 4, and we have to calculate that. When you're doing 1 over 3 minus 1 over 2, you can do a common denominator here of 6. You'll have a minus 1 over 6. Here you're doing a common denominator of a 20. 5 goes in 20 4 times and you'll have a minus 1 over 20. That's exactly what you have. So this definitely has no common difference developing. It's not an arithmetic sequence. But what about geometric sequence? Would it be, pick the same numbers, x to the n and xn minus 1. You'll have 1 over 3 divided by 1 over 2. The 1 and the one before, the quotient of the two, and you'll have 1 over 5 divided by 1 over 4. So when you're evaluating this to see exactly what the ratio is, you're doing 1 over 3 times 2 over 1, you get a 2 over 3 here. You're getting a ratio here of a 2 over 3. When you're doing this, 1 over 5 times 4 over 1, you're getting a ratio of 4 over 5, and you definitely don't see a common ratio, and it's not a geometric sequence either. So this specific series here is not arithmetic, it's not geometric, it's neither. And with that, we end this video. Thank you for watching. Have a good day. Bye.